Welcome to JB's Academy of Science. In this lesson, we are going to learn about Coulomb's law in vector form, unit of charge, that is definition of 1 coulomb, force between multiple charges, and problems on Coulomb's law. Coulomb's law. Coulomb's law gives the magnitude of the force between two charges. We know that two charges will attract or repel depending on the nature of the charges. So consider two charges Q1 and Q2. Now these two charges will attract or repel with a force, and Coulomb's law gives the magnitude of that force. Coulomb's law states that the force between 2 point charges is directly proportional to the product of the magnitude of their charges and inversely proportional to the square of the distance between them. So here we have two charges Q1 and Q2 separated by a distance r. Then according to Coulomb's law, the force is proportional to Q1, Q2, F proportional to 1 by r square. Combining these two, F proportional to Q1, Q2 divided by r square. The proportionality can be replaced by introducing a proportionality constant. So, F is equal to K Q1, Q2 divided by r square. Or F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square, where K is equal to 1 by 4 pi epsilon 0. Epsilon 0 is called permittivity of free space. Its value is given by 8.85 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Substituting the value of epsilon 0, the K is equal to 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power of 9 Newton meter square per Coulomb square. Now, if these two charges are placed in a medium, the force between them will change. The new force will be F is equal to 1 by 4 pi epsilon Q1 Q2 divided by r square, where epsilon is a constant called permittivity of the medium. We can also write epsilon is equal to epsilon 0 into epsilon r, or epsilon r is equal to epsilon divided by epsilon 0. Epsilon r is a constant of that medium. We call relative permittivity or dielectric constant of the medium. So relative permittivity or dielectric constant of a medium is defined as the ratio of permittivity of the medium to the permittivity of free space. Remember, epsilon r, dielectric constant, is a unitless, dimensionless quantity because it is a pure ratio. So it doesn't have units and dimensions. Unit of charge. Definition of Coulomb. Definition of Coulomb. 1 coulomb is that amount of charge which, when placed in free space at a distance of 1 meter from an equal and similar charge, repel each other with a force of 9 into 10 to the power of 9 Newton. Let us understand this. Consider two charges separated by 1 meter. Two equal charges separated by 1 meter. Force between the two charges by Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. Here r is 1 meter and Q1 and Q2 are equal charges. Q1 is equal to Q2. Now, when Q1, Q2 and R 1 coulomb into 1 coulomb divided by 1 meter square. Force is numerically equal to 1 by 4 pi epsilon 0. That is 9 into 10 to the power of 9 Newton. Therefore, when 1 coulomb charge is placed in free space at a distance of 1 meter from another 1 coulomb charge, the force between them will be 9 into 10 to the power of 9 Newton. So 1 coulomb, we will repeat, is that amount of charge which when placed in free space at a distance of 1 meter from an equal and similar charge repel each other with a force of 9 into 10 to the power of 9 Newton. Coulomb's law in vector form. Consider charges Q1 and Q2 that are separated by a distance r. Now, consider an arbitrary origin O. R1 vector is the position vector of Q1, R2 vector is the position vector of Q2. Now, force on the first charge Q1 by the second charge Q2 is given by F12 vector is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 cap. R12 cap is the unit vector giving the direction of the force. Now, the direction of the force is from second charge to first charge. Force on first charge due to second charge is from second to first charge. Similarly, force on second charge Q2 by the first charge Q1. F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R21 square into R21 cap. So from here, from these two equations, we can see that magnitude 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square is same as 1 by 4 pi epsilon 0 Q1 Q2 divided by R21 square. Only direction changes. That is, force on first charge due to second charge is equal to force on second charge due to first charge, but they are in opposite directions. That is, F12 is equal to minus F21. Here, R12 is equal to R2 minus R1, R21 is equal to R1 minus R2. R12 cap, the unit vector R12 cap is R12 divided by magnitude of R12. Similarly, R21 cap is equal to R21 divided by magnitude of R21. Force between multiple charges. To understand the force between multiple charges, let us consider three charges Q1, Q2 and Q3. Consider an arbitrary origin O. R1 be the position vector of Q1, R2 be the position vector of Q2, and R3 be the position vector of Q3. Now, the force between Q1 and Q2 is given by F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 cap. This is the force on Q1 due to Q2. So this is represented by F12. Direction is as shown in the figure. It is from Q2 to Q1. Similarly, the force between Q1 and Q3, F13 is equal to 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square R13 cap. The force is represented by F13 and the direction is shown in the figure. Direction is from Q3 to Q1. Now, the net force on Q1 due to Q2 and Q3. F1 is equal to F12 plus F13. Vector sum of both the forces, which is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 cap plus 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square R13 cap. Now this is the case of three charges. When you consider a system of three charges, force on any one charge due to the other two charges. Now let us consider n number of charges. If there are n number of charges, the net force F1 is equal to F12 plus F13 plus F14 plus etc. up to F1n. This is the net force on Q1 due to the other n charges. We can write that F1 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square R12 cap plus 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square R13 cap plus 1 by 4 pi epsilon 0 Q1 Q4 divided by R14 square R14 cap plus etc. up to 1 by 4 pi epsilon 0 Q1 Qn divided by R1n square R1n cap. Now we can write the net force using sigma notation as a summation of all the forces. F1 is equal to 1 by 4 pi epsilon 0 Q1 sigma I is equal to 2 to n Qi divided by R1I square R1I cap. That is the force on the charge Q1 due to all the other charges. Now, problems on Coulomb's law. Two charges plus 10 microcoulomb and minus 15 microcoulomb are placed in free space at a distance of 50 centimeter from each other. What is the magnitude and nature of the force between them? Q1 is equal to plus 10 microcoulomb, Q2 is equal to minus 15 microcoulomb, R is equal to 50 centimeter, that is 0.5 meter. By Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Substituting the values, F is equal to 9 into 10 to the power of 9, that is 1 by 4 pi epsilon 0 into 10 into 10 to the power of minus 6 into 15 into 10 to the power of minus 6 divided by 0.5 square, which is equal to 5.4 Newton. The force, nature of the force is attractive as the charges are unlike charges. Second problem. The distance between two charges of plus 20 microcoulomb and plus 15 microcoulomb is 100 centimeter. Find the position of the point between them where a charge of minus 2 microcoulomb placed is at equilibrium. So here, consider the charges plus 20 microcoulomb and plus 15 microcoulomb. They are separated by a distance of 100 centimeter, that is 1 meter. And another charge minus 2 microcoulomb is placed at a point in between them, and it is in equilibrium. That is, the force due to both the charges will be cancelled out, or force will be equal. Now, consider x as the distance of the equilibrium position from plus 20 microcoulomb charge. To be in equilibrium, F1 is equal to F2, that is 1 by 4 pi epsilon 0 Q1 into 2 into 10 to the power of minus 6 divided by x square is equal to 1 by 4 pi epsilon 0 Q2 into 2 into 10 to the power of minus 6 divided by 1 minus x whole square. So 1 by 4 pi equating, and we can cancel out the common terms. 1 by 4 pi epsilon 0 will be cancelled. 2 into 10 to the power of minus 6 can be cancelled. We can simplify this and solve the quadratic equation. Solving, the value of x will be 0.54 meter. That is, the equilibrium position is at 54 centimeter from 20 microcoulomb charge. Here are some problems for practice. Answer is given for you. You can solve yourself and compare the answers. Thanks for watching this video. Much more videos will be published soon on other concepts. Thank you.